Good morning, students. Welcome to class 11, especially in physics class. Up to class 10, you have studied physics in science in an integrated manner. But now we have to study it as a separate subject. Today, we will take first unit of class 11 physics. Although there are number of units, as we are starting first unit, that is physical word and measurement. It will start with the basic concepts which you are familiar with, and after that we will take new topics. So here you can see your first unit is unit 1, that is physical word and measurement. So when we are studying this unit, so first of all I would like to share that what is science. As physics, obviously it is a branch of science. See, it is a systematic, organized knowledge gathered through observation and experiments. Let me make it more simple. See, how to get arrangement, how to get organized knowledge through observation and experiments. You can take any example, like when an object is falling downward. Suppose a ball is falling downward, a paper is falling downward, a balloon is falling downward. It means when the things are falling, they are moving towards earth. What can be the reason? First thing, a small child can conclude that all these objects of different size and masses, they are coming downward. So this is the observation from the child point of view. Then he may start it by throwing different objects. This is the experimental approach. So science help you to develop experimental approach, to learn the things in an experimental way, by learning by doing methods. So here science is, here we get the knowledge by organizing the things in our mind. The things are happening around us and we have to learn them by doing, by different activities. So this is basically science. Now we are coming to our branch, that is physics. We are taking it as our branch because our subject is physics. So physics is a branch of science in which we study nature and natural phenomena. See, your first unit is physical world. That means that physical world that is present in your surrounding. Everything in your surrounding is related with physics in the form of nature and natural phenomena. And measurement. Measurement, that means physics is a science of measurement. Physics is a science of measurement. How? How can you say is it my science of measurement? Let me take simple examples. When you look at the clock, you say time is passing 1 hour, 2 hour. When you measure your mass or weight, you are doing the measurement. When you have a pen, this pen in your hand, and you want to measure its length, you will use a ruler, a scale, and then with the help of it, you will do measurement. So what is all this? This is a measurement. So that's why we will take physics as a branch of science in which we study nature and natural phenomena in one manner, and it is also the science of measurement where we can measure different quantities. Physics, it's a vast branch of science. Here we study different branches of physics. There can be many more branches of physics. I have named few. Mechanics. Mechanics is a branch of physics which deals with motion of objects, rest or motion of the object. Optics. Optics you have studied in class 10, where you have studied light, reflection, refraction, scattering. That means phenomena that are related to the light. Thermodynamics. Thermal, heat, temperature. That means a branch of physics which is dealing with heat and temperature. Electrodynamics. Electric and magnetic phenomena related with the charges. Quantum physics. Mechanical behavior of submicroscopic particles. Submicroscopic particles means if you study atom, You are familiar with electrons, protons, nucleus. In the nucleus, further neutron may get converted into proton. Proton may get converted into neutron. There may be very minute particles, alpha particle, beta particle. That conversion can be there. So all that we will study in quantum physics. Now, coming to the term physical quantity. Basically, what is physical quantity? A quantity which can be measured directly or indirectly, and in terms of which laws of physics can be expressed. So, what is the meaning that it can be measured directly or indirectly? So, as you are familiar that if you have to measure mass, length, time, you can simply measure it with the help of measuring apparatus, instrument. Suppose if you have to measure force, acceleration, momentum, many more such kind of quantities. How can you measure them? Suppose you have to measure acceleration, momentum. What you will do? If mass of an object is known to you, momentum is mass into velocity. So velocity you can get by certain means. So unless and until when mass is multiplied by velocity, you will not get momentum. So basically this indirect method is there, that in which we cannot use direct tool for measuring any physical quantity. Then we have to use certain formula. Then we have to use some indirect method. So what you have to learn in this definition, simply it is a physical quantity which can be measured directly or indirectly, and in terms of which laws of physics can be expressed. Lord Kelvin, a physicist who has expressed it in a very beautiful manner. What? What is it? When you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot express it in numbers, your knowledge is mere unsatisfactory kind. In simple terms, it means if you know something and you can express it in a simple manner to others and it is understood by others, that is a knowledge. If you are not able to impart your knowledge to others, then it is of unsatisfactory kind. Now, after the term physical quantity, next we are coming to the term measurement. Measurement. We are taking chapter name measurement. This measurement, what is the meaning of measurement? Here it is a comparison of physical quantity with another physical quantity of same kind. Basically, we have to measure certain quantity like length, and in which standard unit it will be measured. That means in which standard unit you are measuring it. That is a comparison process. See, if length is to be measured, then you have to compare it with meter, centimeter, kilometer. You cannot compare length with kilogram, second. So it means suitable quantity to be compared for it. So simply it is a comparison of physical quantity with another quantity of same kind. Same kind means same category you are taking. Now coming to unit. Yes, this is the standard with which a quantity is compared. So a standard chosen with which a physical quantity of same kind is compared for measuring it. Now, for measurement of physical quantity, what we require? We require two terms, a numerical value of physical quantity and a unit, size of unit. What does it mean? Let me take it as symbolically physical quantity can be represented by Q or X, whatever symbol you would like to take. Numerical value and in numeral N. U is a unit. Like, let me take it as if length of an object is taken as a physical quantity and it is 5 meter. If length is 5 meters, 5 here is numerical value, that is N. M, meter, that is a unit. So it means when you want to measure length, you require numerical value as well as unit. See, if we want to convert it into centimeter, you are taking This is 5 into 100, 500 centimeter. So what you are observing here, when length is compared with a unit, and in these two cases, when you are comparing it first with meter, then with centimeter, which factor is changing? Along with the unit, numerical value is changing. It means the quantity is changing? No, quantity is same. Suppose I am taking this pen. What you observe, this pen can be a length of 12 centimeter, 15 centimeter. I can express it in meter also. What will you do? You will divide it by 100, 12 by 100 meter. So, is it the length of object is changing? No, length is remaining to be the same. What is changing? Our measurement, our choice of unit is changing. And as the unit is changing, so the numerical value will be changing. So, similarly, if we are taking another physical quantity, time, let time equal to be 1 hour. So if you want to convert it into minutes, it is 60 minutes, or in second, it can be 3600 second. So what conclusion you are getting? This particular concept, this particular all concept is quite important. Here this can be justification can be asked. See, here we are observing the quantity is remaining to be same within the conversion, but numerical value as well as unit are changing. It means their product will be constant. Or in a much simple manner, what we can say that numerical value is changing along with the unit. Numerical value is changing along with the unit. That means if we are taking length, suppose quantity is length, numerical value is 5 and unit is meter. And it is 500 in another measurement unit and unit is centimeter. So quantity is same. But in different system of units, the units may change the numerical value. So what we conclude? You have observed from this example, if bigger is a unit, smaller is the numerical value. Here, smaller is the unit, bigger is the numerical value. So it means if U1 is greater than U2, then N1 will be less than N2. Or you can simplify it from here, N1 upon N2 equal to U2 upon U1. N is inversely proportional to U. If U is big, N will be small, and vice versa. So what you conclude from this, that N is inversely proportional to U. Numerical value is inversely proportional to unit. So from this all explanation, this physical quantity measurement, what you have to remember, this result and this particular point and this point. These all are related with each other. This is simply a single point, but in nutshell you have to remember that quantity Q is equal to Nu given by this one and this one. Now next we have to study characteristics of a unit, characteristic of physical unit. See, whatever unit we are using for measurement of a physical quantity, it should follow certain rules. What are those? First, it should be well sized, proper size, convenient size, not too big, not too small. It should be well defined, accurately defined. Like we have taken for the measurement of length, unit can be kilometer, meter, centimeter, millimeter. So it is properly defined and proper conversion are there. It should be easily accessible and reproducible, as whatever physical quantity we are measuring in particular physical unit. So for that, certain measuring instruments should be easily accessible, like we have to measure the length of this pen. For this we require a scale for it, so it is easily accessible for everywhere. And the most important thing, whatever units we are using, that are internationally acceptable. Why? Because at all the fronts, at all over the world, all over India, wherever we are using it, throughout the world, that same unit will be used for measurement of length, measurement of time, measurement of mass, likewise other quantities. And it should not be affected by the change of place, time and physical condition. It should not be affected by the change of place, time and physical quantity. Like this is a pen. I'm again taking the example of pen because this is easily available for me at this time. Like I have to measure the length of this pen at this In my room, I'm taking it, this will be approximately 12 centimeter. When you will measure the length of your pen, that can also be 12 meter, yes, 12 centimeter. It will not change. It means when the place is changing, when I am giving lecture here and you are attending there, so if you have the same company pen, the length will be same. The quantity will not change if you're measuring the same length. Like in a similar manner, there can be many different physical quantities that can never be changed with the place, time, and the physical condition. Like if there is humidity, can you imagine the mass of an object is changed, or the length is changed, time is changed? We are not taking such thing. It means whatever units that have been selected, that should not be changed with such condition. So these all points just for remembering. Sometimes the question can be asked that write down the characteristics of a unit, or what are the choices for the selection of a unit, then you have to write it. So this is a characteristic of physical unit. Now, as we have taken the concept of physical quantity, now we will categorize this physical quantity as fundamental quantity and derived quantities. Fundamental means basic. It means the quantities which are not defined in terms of other physical quantity. That means some basic quantity, their splitting cannot be there. How? You can take it as mass, length, time. So when you have to measure these quantities, you are taking initial quantity as this one. But when you have to measure, like you have to measure speed, you require distance per unit time. So you have to measure length and time. So basically the quantities which are not defined in terms of other physical quantity, those are fundamental quantities. However, there are 7 basic or fundamental quantities and 2 supplementary quantities. Supplementary quantities. How? As 7 basic quantities, we are categorizing them as mass, length, time, current, temperature, luminous intensity, and this should be amount of substance. Amount of substance. These are 7 basic quantities. And 2 supplementary quantities. Supplementary quantities are plane angle and solid angle. So these physical quantities, these fundamental quantities, basic and supplementary quantities. Now few quantities terms you are familiar with: mass, length, time, temperature, current, and 2 more quantities are there that are new one. And supplementary quantities we are discussing here: plane angle and solid angle. We will explain it what are these two. First of all, we are just defining, we are just introducing these two terms. So fundamental quantities, that are the basic quantities, and derived quantities. Derived quantities which can be obtained using fundamental quantities. How can you say? Suppose if you have to measure speed. For measurement of speed, what we require, that is distance. It means length upon time. You can say it as distance covered, rather it is more accurate, distance upon time. So speed is a derived quantity. It is obtained by taking fundamental quantities. Time is fundamental quantity, distance is fundamental quantity. So this is an example which is derived physical quantity. Likewise, we can take it as force. This is obtained as mass into acceleration. So it is obtained by combining these two quantities, out of which mass is a fundamental quantity and acceleration itself is again a derived quantity. So here derived quantities which can be obtained using fundamental quantities. Example: velocity, acceleration, force, momentum, impulse, many more quantities. Now the units of fundamental and derived quantities. Fundamental units. So the units which are used for measurement of fundamental quantities. The units which are used for measurement of basic or fundamental quantities are base or fundamental units. Now derived units. The units which can be derived from fundamental units. That means these are the units of derived physical quantity, obviously obtained from fundamental units. So now these are 2 units. Now here we will study the unit of basic quantities. Here we have 7 basic quantities. That is mass, its unit is kilogram. Length, unit is meter. Time, its unit is second. Current, unit ampere. Temperature, having unit Kelvin. Now two more new quantities which you are not familiar with. Luminous intensity, its unit is candela. Basically it is used to measure intensity of light. Amount of substance, unit mole. This you will also study in chemistry also. So these are 7 basic or fundamental quantities and their units. Now, unit of supplementary quantities. There are basically 2 supplementary quantities, plane angle and solid angle. So unit of plane angle is radian and solid angle is steradian. So here we have to understand the concept of radian and steradian. Basically the angle you use in general terms, that is expressed in radian. And how to distinguish between these two. First of all, let me take for the radian. As radian, it is defined as the angle subtended at the center of a circle by an arc of length equal to the radius of circle. What is the meaning? Let's see there. That we are taking a circle. Like this is the radius having center O. Now, if we are taking any arc length, any small or big, let L is the length AB. This is the arc length, and now this arc, this point and this point, when they are joined to O. So when this arc is subtending certain angle at the center of the circle, so this is plane angle and it is measured in radian. So if you are math student, then you can know that angle is given by arc length per unit radius. So in this way you are defining radian. So see here it is defined as the angle subtended at the center of a circle by an arc of length equal to radius of the circle, and measurement will be theta is equal to L upon R. Although this definition is never asked in the exam, but for clarity of concept we have explained it. This is radian. Now next is steradian. This is steradian. Now basically radian is the angle subtended at the center of circle, and solid angle steradian, its unit is steradian is the unit of solid angle. So this is related somewhere with the sphere. You can imagine that circle is two-dimensional object we can draw on the paper or the board, but solid object like sphere, this cannot be drawn because it's three-dimensional view cannot be there. So imagine, how can we understand it as steradian? For the steradian, let me take, this is just front view of, we are taking a ball. So if we say like this is a, suppose you can say my hand is taking as a part of this ball, like this is a spherical ball. If I am drawing this one square over here, or I am taking one circle over here, so and I am taking this view here. So if this is a sphere and I am taking any surface over this, you can, how can you judge it? You can take a ball at your home. Everywhere everyone has a ball. You can draw a circle, a square, or any irregular surface. Now all the point of this surface, when you join to the center, so this is the angle subtended by this surface. This angle is taken as solid angle. You can imagine, so this is a center, and suppose this is a particular area element, area, not a length. The difference is in circle, here we are taking only length element, but in sphere you are taking any circle. It means it's a particular area element. That means if this is an area element and this is a center, and all its points when joined with the center, the angle subtended at its center is taken as a solid angle. So it is defined as the angle subtended at the center of a sphere by the surface of the sphere. This is the surface of the sphere, equal in area to that of square of radius of the sphere. This square of radius of the sphere. So here Stradian, I have given the statement here which I have explained. Now Stradian, it is taken as surface area per unit square of radius, and symbolically it is represented by this symbol. You can just compare it with the unit ohm you have studied in Ohm's law. You can just relate it that this is taken as the unit for Stradian. So I think there is no need to learn this statement. You have to understand the concept. So plane angle is related with the circle and solid angle is related with the sphere, and the units are radian and stradians. So the difference between these two must be clear. It should be there. So my dear students, today we have introduced some basic concepts, and I want you to familiar with these concepts so that we will further proceed our topics one by one. I hope you have understood all the concepts. So learn these concepts, practice these concepts. If you have any doubt, you can ask me. Moreover, this is a time when we are bound to stay at home. So taking all the precautions, you must take care of your health. Stay home, stay safe. Thank you. Have a nice day.